Alright, so the last part I actually want to show you is how to find the angle theta that defines this triangle using the lengths of each side. There are other ways to do this, but for a right triangle it's really simple. We can just apply the trig functions that we already know. So if I wanted to find angle theta by, say, B and C, we would use our sine function. And as we know, sine of the angle theta equals B, the opposite side over the adjacent side, hypotenuse. Now, we cannot just divide this function by sine, because sine is a function of itself. It needs an argument. And so this would just yield gibberish. What we can do, however, is use our sine inverse function of, or as it's also called, it's the arc sine. Right? Now the argument for the arc sine and the sine inverse function is going to be the same. Right? It's going to be the defining sides. Right? Because if it's the inverse, it's that. So if you have the angle theta, or if you want to know the angle theta, you can say that it's equal to the arc sine of the two sides that define it, B over C. And this will yield you an angle defined in radians. Okay? Now, for the arc sine, arc cosine, and arc tangent functions, right? We have arc sine, arc cosine, arc tangent, right? Each one of these is going to yield the angle theta in using different arguments for each one. So for arc sine, we already said that it would be B over C. For our cosine, it would be A over C. And for our tangent, of course, it's going to be B over A. And each one of these should yield the same angle theta if done properly. Now, this can be very useful, say, if all you know or all you can measure is the length of these sides.